And now we're going to get to steroids. Now the Martini book, it has like it calls them lipid derivatives, but for this class I just want you to focus on in terms of hormone signaling, focus on the steroids. This is the classic is canon that they are lipid derived hormones. Now lipids, you might be like, what are lipids? Well, if you don't know what lipids are, go back to chapter 2 of the book. So things like fats, oils, waxes, the things that don't dissolve in water easily, in general, those are the lipids in our body. And sometimes you have those exceptions. But again, that's why I have my chemistry lectures on and biochemistry lectures up on my channel. All right, so what are the lipid-derived chemical signaling factors? Again, for this class, focus on steroids. Now, eicosanoids, this is if you're using the Martini version of the book. For eicosanoids, not that they're not important, but they're important signaling molecules, but I think this is something more if you're going on to advanced studies, if you're doing, especially if you're going into immunology or taking an immunology class, you kind of need to know these. Now, Martini classifies these as hormones, and I don't quite agree with that because it's all about the scope and range of these molecules and where they go and how big of an effect they have and how wide of an effect they have. So eicosanoids, they act more like paracrine factors, so they act in more of a local fashion versus the whole body. So it's very important in things like inflammation. Like if you have some like a insect bite or if you have some sort of infection, maybe you want inflammation in the area that has that pathogen and that infection, but do you want your whole body swelling up with inflammation in response to just a local threat? So this is why I don't quite agree with it as hormones. They could act in a hormone, but typically eicosanoids are more of a local than global thing. Now, in the OpenStax, if you look for, I mean, maybe I missed it, but I use the search function, it doesn't even talk about eicosanoids. So, end message, don't worry about eicosanoids for this class. Not that it's not important, but I think these things are a topic that's more, I mean, it's easier to talk about when you have more of this knowledge of basic cell signaling and immunology under your belt. Then you can learn more about that. Now, the funny thing is like steroids. Okay, so let's talk about steroids. So why are they called steroids? And you might be like, oh, steroids, aren't those the things that can get people banned from the Olympics? And yes, that is correct. But steroids, they're called steroids because they're all made from cholesterol. So when I say derived from, that means that somewhere they start with cholesterol somewhere, and then through all these enzymes and chemical reactions, you eventually have a steroid. So that's how you make steroid hormones, and they all come from this molecule. And what you notice is that, okay, we have, remember those hexagons and pentagons I talked about? Well, remember with the the monoamine hormones, we had either just one hexagon or hexagon and pentagon. But with steroids, notice that they're a little more, or actually, well, they're more complex. Instead of just like a hexagon and a pentagon or just one hexagon, now you have three hexagons and a pentagon. Again, I'm not going to say like delete one of these groups and tell you like, is this a steroid, is this cholesterol or not? Again, that's more of organic chemistry and biochemistry at the upper division level. For this class, I just want you to know just what the general shape of a steroid looks like. And if you look at all these steroids here, these human steroid hormones, so it's not just about the anabolic steroids that you hear about, like, oh, so-and-so got banned from the Olympics because they test positive for steroids, or things like bodybuilding as well. Yeah, we have things like testosterone, andro, DHT over here, but you also have estradiol, which is the main estrogen in the body. And then you also have things like aldosterone, and you might be familiar with cortisol as well. So again, if you hear about steroids, you might say like something's on steroids. But is it an anabolic steroid? Is it a catabolic steroid? Is it glucocorticoid? Is it mineralocorticoid? Again, just because they look very similar, and notice that all these steroids, they have that three hexagons and a pentagon. It's just these things dangling off from it that differ between the different steroids. But these things that dangle off, these made this main what we call a four-ring structure, is what determines its property and determines the effects it has. So again, but in general, they do share common properties, but once they're the final steroids here, they all have their own different properties, but they do have some commonalities, including their structure. So again, that four-ring structure, that's a classic sign that some compound And there's also some drugs that have steroid-like structures as well. So if you see this kind of four-ring structure in a drug structure, then you might be like, okay, this probably has steroid-like effects and probably lasts for a long time like steroids as well.